Alright, what's going on, guys? So, Mr. Flores here, and this video here is going to deal with something called Cramer's rule. Alright, and basically what Cramer's rule is, it lets you solve systems of equations quicker and by using matrices. Alright, so what we're going to have here is we're going to have a 2 by 2, I mean not 2 by 2, we have a system of two equations where it's x minus 3y equals 4, 5x plus 7y equals 8. Alright, and when you're solving a system of equations using matrices, aka Cramer's rule, the first thing you need to do is get your coefficients and put them in a matrix, okay? And what I mean by that is you're going to take all the coefficients of x, put them in a column, so 1x and 5x, so 1 and 5. Then you take your y's and also make them your second column. So this is your x's, that's your y's. All right, and we're going to do something with the 4 and the 8, which is your, which is what each equation equals. But just yet, we're going to have to do something else. So the first thing you want to find is you want to find the determinant of this. So I'm going to call this C for our coefficients. And when we find the determinant, it's going to be 1 times 7 minus 5 times negative 3. Okay, which is going to give us 7 minus negative 15. This becomes a plus, so 7 plus 15 is 22. All right. So now 22 is an important number for us because we're going to be using this to divide other determinants in order to find out what x and y equal. All right. So now what you want to do is let's set up our coefficient. I'm going to call it CX. Matrix, okay? Because what we're going to be doing is using the determinant of this matrix I create and the 22, which was the determinant of the coefficient matrix, we're going to be able to find out what is x in our equation, okay? So what you want to do is whichever variable you want to solve for, aka in this case it's going to be x, you take your answers, so 4 and 8, and you just write them in that column. So instead of writing 1, 5, I'm going to write 4, 8. Then you still rewrite the y column. Okay, so again, I got this column because this is your answer. This is your solution, basically, to the systems. And this is still your y. Okay, since we took out the x column with our answer or whatever each equation is equal to, that is going to give us what x is actually equal to. So again, the determinant of this is going to be equal to 4 times 7 minus 8 times negative 3, which is going to come out to 28 minus negative 24, which again is going to be a plus, so it's going to be, what is that, 52? Okay, so the x variable, you take this determinant of 52 and you divide it by the determinant of your actual answer. Okay. All right, and then when you simplify, your answer is 2.5. Okay, so now what we need to do is we need to find the answer to our y variable. So C of y is going to be equal to, okay, since we don't want to solve for x, we're going to just rewrite the original coefficients of x, which was 1 and 5. Now in the y column, we're going to put our answers to each equation, which is 4 and 8. This is x, and this is your solutions. Okay, and again, we need to find the determinant of this matrix. Okay, so it's going to be 1 times 8 minus 4 times 5, which is 8 minus 20, or negative 12. Okay, and then your y variable is negative 12 over 22, which comes out to negative 0.55. Okay, so now our solution to this whole thing is 2.5 comma negative 0.55. Okay, because in a nutshell, we could have solved this system using substitution or elimination, or we could have graphed it, and you would have gotten the same solution. Okay, now this seems like a lot of work to do for a 2 by 2 matrix. As opposed to just doing substitution or elimination, okay? But when we get to a 3 by 3 matrix, it actually makes our life a lot easier. Okay. So what I have here is I have a system of 3 equations. I have a video of solving this by using substitution. It gets very, very tedious and strenuous because it's just a lot of work. Okay. But again, the first matrix you're going to make is your coefficient matrix. Okay, so you're going to put all the x coefficients in one column, y's and z's in the other. So it's going to be 2, 1, 1, 1, negative 1, 2. Make sure since it's negative y, you put negative 1, and then 1, negative 1, 1. Okay, the reason why there's a lot of ones and stuff is just because it's going to make our calculations easier. So again, the first thing you always do is take the determinant of your coefficient matrix. Okay, and again, to take the determinant with a 3 by 3, you rewrite the first 2 columns, and then you take your down diagonals and add them. So it's going to be 2 times negative 1 times 1 is just negative 2. 1 times negative 1 times 1 is negative 1. 1 times 1 times 2 is 2. So for our answer, it's negative 2 plus negative 1 plus 2. All right, now we got to get our up diagonals and subtract them. So 1 times negative 1 times 1 is negative 1. 2 times negative 1 times 2 is negative 4. 1 times 1 times 1 is just 1. So it's going to be minus negative 1 minus negative 4 minus 1. Okay, so then when we simplify, it becomes negative 2 minus 1 plus 2 plus 1 plus 4 minus 1 for a grand total of negative 3, negative 1, 0, 4. Okay, so our coefficient determinant gives us the number 3. Okay, and that's useful because we're going to need that when we are creating the rest of our when we're solving for the rest of the variables. Okay, so what I'm going to do here is I'm going to make our x determinant, or our x matrix. Okay, and again, when we're solving for the x variable, you replace the column of the x coefficients with the column of your answers. Okay, so it's going to be instead of 2, 1, 1, because it's 2, 1, 1, you're going to put 3, 0, 0 in that column. Okay. Oops, and this is supposed to be a 2 actually. And that's why, again, the hardest thing with these problems is they become very tedious just in the bookkeeping, just because there's a lot of stuff you have to do. There's a lot of like little things you have to pay attention to. So I'm going to take this and move down here, just to have some room to solve it. Okay, and again, to take the determinant of this, we have to first rewrite the first and second column. Okay, so I'm going to write 3, 0, 0, 1, negative 1, 2. All right, and again, we're going to have to find the determinant of this. So the down diagonal, it's going to be negative 3, 0, and 0, which is nice. So it's really just negative 3 plus 0 plus 0. The up diagonal is going to be 0, negative 6, and 0. So it's going to be minus 0 minus negative 6 minus 0. So we're going to have a total of negative 3 plus 0 plus 0 minus 0 plus 6 minus 0. Or it's just going to equal 3. Okay. So now what we're going to do, in order to find out what is x equal, okay, we're going to take the answer from our x coefficient determinant, where we change the x column, and we're going to divide that by the answer to our original coefficient determinant. So 3 divided by 3 is 1, and the value of x in this system of equations is 1. Okay. Now, what we want to do is we want to also go back and find y. So again, what I'm going to do is I'm going to write the y coefficient matrix. Okay. So instead of writing the y column, I'm going to write the answers there. So the first column is going to be 2, 1, 1, then 3, 0, 0, 1, negative 1, positive 1. Okay. And again, we have to find the determinant of the determinant of this matrix. And then once we find the determinant of it, oops, hit the wrong button. All right, once we find the determinant of it, we're going to do some division, some solving, and we'll be good. Here, one second. Alright, so I just wanted to rewrite these matrices so we don't have to waste time. So if you look, I have the coefficient of y, because we're going to solve for the y matrix, the y variable. What it is, I just rewrote the original matrix using the coefficients. Instead of the y column and the second column, I put the answer. Same thing with the z, the coefficient of z. I just rewrote it, and then in the third column, I put the answers. All right, so we got to find the determinant of both these by rewriting. Okay, so we're going to do 2 times 0 times 1 is 0. 3 times 1 times negative 1 is negative 3. 1 times 1 times 0 is 0. Okay, so the determinant's going to be 0 minus 3. 0 plus negative 3 plus 0, since those are our down diagonals. Now we have to find our up diagonals and subtract it. So 1 times 0 times 1 is 0. 0, negative 2, 0, negative 1, 2 is 0. 1, 1, and 3 is 3. So it's minus 0, minus 0, minus 3. So it becomes 0 minus 3 plus 0 minus 0 minus 0 minus 3, which gives us a negative 6. Okay, so now for our y value, you're going to take the negative 6 and we're going to divide that by the answer to the first determinant we found, which was a 3. So negative 6 divided by 3 is negative 2. So the solution to this system for y is negative 2. Okay, now we're going to find the z coordinate. So we take the determinant. Oops, that's supposed to be a positive one. Negative 1 and 2. Alright, so we're going to take our down diagonals. You get 0, down diagonal. You get 0, down diagonal. You get 6. So it's 0 plus 0 plus 6. Then we're going to take an up diagonal, which is going to be negative 3. Up diagonal is 0. Up diagonal is 0. So it's minus negative 3 minus 0. Oops, not like that. Minus 0 minus 0. So it's 0 plus 0. Made a lot of mistakes. It's early. Plus 6 plus 3 minus 0 minus 0. So that gives us an answer of 9. Okay. Now again, the z, it's going to become z is equal to 9 divided by, since 9 is the answer to the coefficient of the z matrix, we must also go to our original determinant, which was another 3. So it's 9 divided by 3 is equal to 3. Okay, so you're going to get your solution. We're going to write as a coordinate pair. X is 1, y is negative 2, z is 3. And I just wrote that wrong. X is 1. Y is negative 2, z is 3. Okay, so if you were to solve this system using substitution, elimination, or even graphically, which you can't graph this because it's three-dimensional and that gets crazy hard unless you have a computer, you would have gotten your answer to be x is 1, y is negative 2, z is 3. All right, I know this is a long process. Once you get good with determinants, it becomes pretty easy, especially if you don't make as many mistakes as I did. It also gets a lot easier. All right, so hopefully you found this video useful. If you have questions, let me know. We're going to do more practice with this. But again, this is the process. You find the determinant of your coefficient matrix. Then whatever variable you want to solve for, you replace that column with your answer column. Find the determinant, and then you do some division. All right. Hopefully you learned some. And check out the rest of the website.